Hello, we're Team 141 and we were assigned the HDB Resale dataset. My name is Abhishek Sundaraj.
I'm Lars Hoffman.
I'm Antara Rath.
And I'm Robert Ramirez.
Okay, next slide, please. Let's begin by understanding the context of our project. The real estate market plays a critical role in the global economy and in Singapore. Understanding the factors influencing the resale prices of flats is crucial. By leveraging analytics, we aim to empower individuals and businesses to make more informed decisions, driving value for buyers, sellers, and stakeholders alike. Our problem statement focuses on one key question: what factors influence the resale price of flats in Singapore? This is particularly important as these flats are a critical component of the nation's housing market. By addressing this question, we can help stakeholders make data driven decisions. To achieve this, we've outlined two main objectives: to determine which factors are most significant for buyers when comparing real estate options, to identify which factors most or least influence sale prices to help sellers adjust property values effectively. Next slide, please. Moving on to key insights and findings from our analysis, we evaluated multiple regression models to identify the best fit for predicting resale prices. On the left, we have the residual plots for 6 models we tested: linear regression with 5 and 3 factors, log linear regression, multiple linear regression, ridge regression, and lasso regression. These plots show the relationship between residuals and fitted values, helping us evaluate the model's performance. Among these, the multiple linear regression model stood out. Its residuals are the most evenly distributed with minimal patterns indicating a strong fit. To confirm its effectiveness, we also compared adjusted R-squared values, shown in the bar chart on the bottom right. The multiple linear regression model achieved the highest adjusted R-squared value, further validating its predictive power. In conclusion, residual analysis and adjusted R-squared comparisons reveal that multiple linear regression is the best performing model for this dataset. This allows us to confidently use it for predicting HDB resale prices with accuracy and reliability. Now I'll hand it over to Lars Offerman.
Thank you, Abhishek. As mentioned, we chose our multiple linear regression model as the final model for predicting resale price. This model overall consisted of 4 factors: the floor area in meters squared, the distance to mass rapid transit system in Singapore, the months remaining on a 100-year lease, and the total duration of a lease in years. Since this model was linear, the overall implication of the model is pretty easy to understand, since the factors either have positive or negative effects on the overall resale price. This means that both buyers and sellers can directly choose which factors to improve upon or invest into when trying to increase or decrease the overall resale price. Some strategic value for businesses is that using these factors and their overall influences, you can create some sort of impact per factor. One of the impacts is the floor area. Since it has an overall large influence on increasing the price, you could work with the floor area to overall affect the resale price. The distance to the MRT has a slight influence on an increasing price. The months remaining on the 100-year lease has a slight decrease influence on the price, and the total duration of lease in years has a larger influence of the decrease on overall resale price. Next slide, please. With all this said, we can make a couple of recommendations for both our sellers and buyers. Our sellers, we're assuming, should aim to maximize their resale price through strategic investments. Some of these investments include projects to increase their overall floor area, Also, investing in properties that are closer to the MRT since they sell for slightly higher. Finally, some older buildings tend to lose value, so continuous renovations tend to keep the building new and help increase the price. The buyers, we assume, would like to strive to keep a good deal on their real estate and have lower prices. Hence, using our model for a data-driven approach is recommended. The investment in real estate with a smaller overall floor area is recommended, and having a set plan to increase that area after purchasing the property is a recommendation we have for buyers. Also, looking for property that are a little bit further away from the MRT will tend to decrease the overall price of the property. Finally, older properties tend to be less expensive, so buyers on budget may want to research the overall age of the property and look into purchasing property that is older if they're trying to find a better deal on said property. With all this said, I'll go ahead and pass it over to Robert for the implementation plan.
Thank you, Lars. So in this project, we've utilized data and analytics in order to identify the most impactful features that factor into the resale price in this Singapore real estate market. And with this helpful use of data and analytics, we've identified an implementation plan and challenges and considerations based on the recommendations in order to maximize profits for sellers or for buyers, identifying properties with high value based on the key features in our regression model, but perhaps with a lower sale price, which qualify as worthy investments or purchases. So for sellers, determining cost-effective ways to increase usable floor area, such as an open concept design to increase resale price without exceeding the amount of value that could be generated by the increased floor area, would be helpful. Also, identifying and communicating the value of proximity to MRT systems in ads or of the property listings or as a sales pitch would be helpful. Resources involved in these would be for renovations and floor area enhancements, using design and construction partners, and in order to communicate to clients and provide expert support for the seller, utilizing real estate agents and firms. Now, the timeline for this, implementing increased floor area and researching costs and finding resources, this could take 3 to 5 months. Now, researching, identifying, and communicating the value of proximity to MRT systems could take 1 to 5 days. Now, for buyers, creating data-driven tools such as ML models like this to evaluate properties based on identified factors and find anomalies that are underpriced according to the tools used. Also, purchasing property based on desired traits, perhaps further from the MRT with large floor area or vice versa, depending on the preferred higher factor. And the resources for this would include to continuously update and validate the insights from the models. A data and analytics team would be necessary. Also, to provide expert support and guidance for purchasing real estate from sellers. Real estate agents and firms would also be necessary. The timeline for this, implementing data-driven tools, ML models, or hiring a team to evaluate property factor values. This could take 1 to 3 months. Now, researching, identifying real estate agents or firms to give guidance on purchasing real estate, 1 to 5 days. And now I'll move to the next slide. So the next slide is on challenges and considerations involving the implementation plan. So a few things to keep in mind for sellers. Some challenges might include the cost-benefit balance. So determining whether the cost of renovations will exceed the value added to the resale price. The regulatory constraints, so ensuring that renovations comply with Singapore's housing and building regulations. The market perception. Buyers may have varied preferences, with some favoring traditional layouts over the open concept designs. Also, quantifying value, translating proximity to MRT into a clear monetary or lifestyle advantage for prospective buyers. Some considerations and mitigations, incremental investments, so prioritizing the low-cost changes that offer the highest returns first. Market research, conducting surveys or gathering data to assess buyer preferences in the target area. And some insights, using data to highlight specific advantages, such as reduced commute times tied to the MRT proximity in the target area. Now, for buyers, challenges include data quality and availability, so ensuring the data used for training the ML models is accurate, comprehensive, and up to date. Customization for buyers, tailoring the models to account for individual buyer preferences, such as proximity to MRT versus the larger floor areas. And complexity for agents. So perhaps real estate agents may find the ML models complex or intimidating, which might limit their adoption rate of the tool. And considerations and mitigations involved for this: joint decisions, encouraging collaboration between the buyers and the agents, combining the insights from the ML tools with the agent's market knowledge, or hiring real estate agents, or working with firms with data-driven market understanding, and an expertise balance. So just balancing the agent's expertise with the new data-driven approaches from the models. And with that, I'll hand over the next slide to Antura.
Thank you, Robert. So looking ahead, there are several ways we can expand and refine this project. So while the multiple linear regression model performed well, we could improve the accuracy by looking at more advanced nonlinear models, such as gradient boosting, random forests, or neural networks, to look at any hidden patterns or relationships in the data. We could also generate additional features to improve predictive power. For example, we could use a weighted score combining factors, or look at interaction terms to analyze how factors affect each other. We could also conduct a detailed analysis of how broader economic trends such as inflation, GDP growth, etc., could impact resale prices and help stakeholders create strategies. So looking at long-term improvements, we can integrate other data sources that include data on school rankings, healthcare accessibility, or crime rates to look at, provide a more holistic understanding of what influences property value. We could also analyze the return of investment for renovations or infrastructure improvements to see how to guide sellers on which upgrades yield the highest value. And lastly, we could expand the data set to include emerging real estate markets like private or commercial properties to see how this can broaden the project's relevance and scalability. On to the next slide. So in this project, we saw the multiple linear regression model prove to be the best predictor of resale prices. And this is due to the higher adjusted R-square value and having well-distributed residuals. And the four significant factors from this model included floor area, proximity to MRT stations, months remaining on a 100-year lease, and total lease duration in years. And these factors would help buyers and sellers make decisions in the market. These findings also emphasized these findings let buyers and sellers benefit from an approach that combines data and actionable strategies so that they can maximize value in an evolving real estate market. Factors like MRT proximity and flat size lease characteristics are critical for predicting these resale prices. And so in the future, our recommendations would address immediate challenges such as renovation, cost-benefit analysis, and set the stage for long-term improvements with better tools and applications. And this scalable framework can expand to other property types or regions, ensuring for continued relevance and adaptability. Thank you for listening to our presentation.